All right, sixth graders. So since this is the first day that I'm not at school, I wanted to make a video here real quick for you with directions for today and kind of the plan of what it's going to look like each day. So every day you come in, the format's going to kind of be the same. There's going to be a video for you to watch. It's going to be a section of notes from my presentation. You'll need to open up your class notes, which is titled Class Notes, Plate Tectonics, 6H. It's the guided notes where you're filling in as we go. I have done screen recordings where I have my presentation up here on the screen, and I'm going to be talking to you and giving you further information about the content that's on the screen. You're just going to go through and you're going to type and add in to the document just like if I was here, except you're going to be doing it on the screen, okay? Oh, wait a minute. Hold on. I got to erase those names behind me. That looks weird. Wait 1 second. All those names on the board. Okay, much better. So, like I said, the format is that you'll come in. There'll be a video for you to take notes. You'll listen. You'll do your notes. That's obviously going to be something that you're responsible for doing. I will have you guys actually turn your notes in. You're going to share your notes with me at the end of the unit so that I can give you participation points and completion points for just doing your notes. So the expectation is that you're doing them. When you're done with the notes, you and your group will get back together and you will work on the plate boundary map activity. You'll just kind of pick up from where you've left off the day before. So every day you'll come in, you'll do notes off the video. When you and your group are done with the notes, you then will go and work on the plate map. And that takes you through pretty much all the days that I'm gone. If you finish with all of that stuff, the substitute will have additional things that you can work on once you're done with that. But the big thing is that you get the plate map activity done and that you do the notes every single day. If you miss a day because you're absent, you need to make sure that you watch the previous day video as well so that you get yourself caught up on the notes. It will not be an excuse for missing notes that you were absent. Okay, I hope you guys have a good week. I'll have a video every single day, and we'll get through this. And when I come back, we'll just keep going through plate tectonics. All right, have a good day. Here's the video for the notes for today. So now that you have your document open for your notes, remember the document's called Class Notes, Plate Tectonics 6H. And we are down at Roman numeral 6, which is going to be divergent boundaries. So you guys are working on the plate boundary map, and you're using something that looks somewhat similar to what you see here on the screen. But we're going to take notes today on divergent boundaries. And each day when we have a new video, there'll be a new part of a new boundary for you to go through and to learn. So let's talk about divergent boundaries here. A divergent boundary is a place where two plates are being pulled apart, which is caused by tension. And the reason they're being pulled apart is because of those convection currents below in the mantle. So remember with the rice lab that we did, and you have these convection currents doing these circles. And depending on where the plate is, it's either pushing the plate towards another plate, sliding a plate past another plate, or in this instance, pulling plates away from each other. And that's what makes a divergent boundary. So if it's two land plates, two continental plates being pulled apart, we see what's happening here on the right. So the picture here on the right, this is what's happening when it's two continental plates being pulled apart. So you get these cracks forming in the plate like you see up here in the first picture. We call those rifts. New crust then is formed as magma forces up through the rift, which is happening through volcanoes. So it's hard to see, but there are these little volcanoes here, and you can see like the little smoke coming out of them. So that's the next step, okay? Oh, and by the way, at any point here, you can always just hit pause if I'm moving too fast and you're not typing in quick enough, just hit pause, and then you can hit play again, okay? So that's the second thing. You get the new crust form. It's still up here in this first picture. The second picture now is where we see the next step. And that's where you're starting to see this rift valley. And a valley is this lower part of land, right? And this valley is formed from the pulling apart of the plates and the weakening of the crust as well. So you can see where those two volcanoes were up in the first picture, now how they're a little bit further apart, and now you have this rift here. This takes a long time. This is a super slow process, hundreds of thousands of years. And then over the course of even more hundreds to thousands of years, what will happen then is the rift valley gets so large that it starts to fill with water because it's the lowest area. So that's where all the rainwater will always drain to because of gravity. And so you start to get things like lakes. And then they grow into things as big as seas. And they even can form oceans. And once that they're water and they're oceans, this new crust underneath is now oceanic crust that's being formed underneath as the plates have been moving further and further apart. And now we get to what we did in our lab before the rice, and that's the seafloor spreading lab. Now you're getting new seafloor being created underneath this ocean as the ocean gets bigger and bigger. So notice the size of these two. And this one down here is bigger. And so the ocean now is beginning to grow in size. You're getting new seafloor and new rock, and what's happening is where that's happening, with where the seafloor is spreading, that location is where you're also getting the formation of the landform called a mid-ocean ridge. A mid-ocean ridge. And that was represented in our lab by where the two desks were pushed together and where you were pulling up those pieces of paper. That is the mid-ocean ridge. It's like an underwater mountain range, like it says here in the notes. The magma is coming out faster than the ocean floor is spreading, and so it starts to build and build and build. Okay? And the biggest one that we have is out in the Atlantic Ocean, or at least that's the one that was first discovered and helped lead to the theory of plate tectonics. Okay? All right, so as you go through here your notes and you're looking at your document, you now have a table. And in your table, you're going to notice that some of these words are missing. So what I would like you to do is to press pause and pause the video and really pay attention to what's in the chart on the screen right now compared to what is in your document, and make sure that you get everything that's missing. So go through each box individually to make sure you have everything. Go ahead, pause the video now, and when you're done typing all that in, come back to the video and press play, please. So now that you've typed in all this information, let's go through each of them here. Let's start with ocean crust. So what happens? Well, at a divergent boundary, the ocean floor is pulled apart. And the reason it's pulled apart, convection currents in the mantle. Man, we're going to say this a lot, so get used to it. The magma erupts, it forms this rift, and over time, the formation that you get is a mid-ocean ridge. Okay, mid-ocean ridge. And our example of a mid-ocean ridge is the one that runs through the middle of the Atlantic Ocean. So, of course, they come with the easy name, the Mid-Atlantic Ridge. It's right through the middle of the Atlantic Ocean. So that's the landform that you get with oceanic plates being pulled apart at a divergent boundary. When we get to land plates, the continental plates being pulled apart. The land is pulled apart by convection currents in the mantle. The magma erupts and forms a rift. Then you get these rift valleys, right? So these are the valleys like we showed on the previous slide. The other thing that you can get are volcanic mountains. Just like you're going to have these underwater mountain ranges with the water, the same thing's happening here, but because it's above the water, it's literally magma coming out and lava coming out. So they're volcanic mountains that are coming out. And if you remember back on the previous slide, those little volcanoes that we saw at the beginning of the plates being pulled apart. So you can get these volcanic mountains. And sometimes they'll become dormant or extinct because the plates move, and so the volcanoes are no longer at that plate boundary. But volcanic mountains, rift valleys, those are the two land formations that are in a divergent boundary. Our example of those, the African Rift Valley. So the African Rift Valley is in East Africa, and I'll show you a picture right here in a moment. And then Iceland. And Iceland's unique because Iceland also is on the Mid-Atlantic Ridge. And so we'll talk about Iceland a bunch later. There's the Mid-Atlantic Ridge, right through the middle Atlantic Ocean between the North American plate and the Eurasian plate. Okay? And here's a map, and so to know where we're at, take a look down here at the globe here. We're in East Africa, and this is the East African Rift Valley. You can see the name of that right here. And so you see these lakes that are being formed here. That's because we are at a rift valley where the land is literally being pulled apart, and you're getting the formation of these lakes. So that's the example of the Rift Valley. Okay. Remember, as we go through each of these each day, and you're taking these notes, when we eventually have a test, you're going to be responsible for knowing what happens at a divergent boundary, some of the formations that happen because of that boundary, okay, and a little bit about the examples. Not necessarily you're going to need to specifically know the examples, but it's good to know them. But the hardest part of this lesson, I feel, in this unit, is that you have to keep straight, well, what's being formed at each of these different types of boundaries. So these charts are going to be really important for you when it comes time to study. Okay, now that you're done with today's notes, make sure your other group members are ready and done, and as soon as they're done with their notes as well, get your plate activity, your plate boundary map, and work on that activity until the class period ends today. Okay, thanks, and I will have a video for you tomorrow. Bye.